السلام عليكم ورحمة الله وبركاته. Hi everyone. Start your video please. Please start your video. Rename yourself يا عبد المالك. رضا عمر معتز. نور فارس. Start your video. Rename yourself يا نادين. طيب. Our lesson today is talking about operations on real numbers. Operations something like addition, subtraction, multiplying, and dividing, but about the real numbers. And the first thing that we have to study right now that what is the difference between the similar roots and the different roots. The similar roots are something like that: 3 root 5 and 8 root 5. Both are similar. They are similar. This is cubic root 5 and this is cubic root 5. Then they are similar. But something like 3 cubic root 5 and 8 cubic root 7. They are different because this is cubic root 7 and this is cubic root 5. So we are gonna talking about how to add, how to subtract the similar roots firstly, and then we will talk about adding, subtracting, multiplying, dividing all the roots, even they are similar or different. So firstly, who knows? Something like 8 root 7 and 9 root 10. They are similar? They are similar or not? Yes or no? If they are, make like that. If they are not, make like that. They are not. What about 8 root 7 and 9 root 7? They are similar. What about 8 cubic root 7 and 9 square root 7? They are similar? No, because this is cubic root and the other is square root. This is cubic root 7 and the other is only square root 7. If they are similar, then it should be like that: 8 cubic root 7 and 9 also cubic root 7, or 8 square root 7 and 9 square root 7. Both are square roots or both are cubic roots, then they are similar. And the number below the square root must be similar also. But if one is a square root and the other is cubic root, they are not. Okay. Right now we are gonna talking about adding and subtracting real numbers. The title of the lesson is operations on the real numbers. So the operations are addition, subtraction, multiply, and dividing. Firstly, we're gonna talking about the adding and the subtract. Let's take this question, something like that. The most, and the first important thing you have to know that if you wanna add or subtract two real numbers, they must be similar roots. They have different similar roots or different roots, then we cannot add or subtract them. Something like the first example. 1 3 root 7 plus root 7 equals. Answer with me يا عبد المالك. يا عبد المالك 3x plus 4x equals what?
7x.
7x. And if it is 5x plus x, something like 1 here, but we didn't write the 1, then 5x plus 1x equals
5x, 6x.
6x. It's the same. This is like x. If it is 3x plus 1x, then it's gonna be 4x. So if it is 3 root 7 plus 4 root 7, then it's gonna be 4 root 7. That's it.
Okay.
So root 7 here, it's something like the x. If it is 3 root 7 plus 1 root 7, then 3 plus 1 equals 4, and the root 7 is still itself. And you can do it with the calculator. If you have a calculator, write 3 and then
Okay.
square root. This is the bottom of the square root.
3 square root
Plus root 7 equals 4 root 7, like what we did.
plus.
Is it clear?
Yep.
And the next 5 root 3 minus 3 root 3 minus 2 root 3. Answer with me يا محمد الحسين. محمد الحسين, you're doing great.
Yes.
What about Yusuf Al-Hussein?
برضو.
Could you please, Muhammad Al-Hussein, get the camera a bit down, please? Yes. Let me see you. Can see well. Read the question. Thanks.
5 square root of 3 minus 3 square root of 3.
Also, it's something like that. 5y, for an example, minus 3y minus 2y. All of them are similar roots. All of them are similar roots because all of them ends by root 3. Then they are similar roots. They are similar real numbers. 5y minus 3y equals 2y. 2y minus 2y equals
2y minus
2y minus 2y equals, if it is 2y minus 2y equals
0.
0. Then this part, 5 minus 3 equals 2, and then 2 minus 2 equals 0. It's the same. 5 root 3 minus 3 root 3 is going to be 2 root 3 minus another 2 root 3, then it's going to be 0. Okay?
Okay.
Thanks, ya Muhammad Al-Husayn. Answer with me, ya Sufyan. Read the next. Number 3. It's negative cubic root 6 plus 4 cubic root 6 minus 2 cubic root 6. Are they similar roots?
Yes.
Yes, they are similar roots because all of them ends by root 6 and as the same cubic root 6, cubic root 6. You know, if it is something like cubic root 6 plus cubic root 7, we cannot add them. Why we cannot add them? Because they are different roots. One is cubic root 6 and the other is cubic root 7. So only we are adding and subtracting the similar roots. Only we are adding and subtracting the similar roots. Can you tell me, ya Sufyan, firstly, it's negative 1, correct? This is
Yes.
negative 1. Negative
Yes.
1 plus 4.
3.
Yes, excellent. Then this part, write instead of it 3 cubic root 6. That's 3 cubic root 6 minus 2 cubic root 6 equals
1 cube 6, 1 3 cube.
so I can write it like that without the 1. Correct?
Correct. تمام. Okay.
Clear?
Clear.
Any problem?
No.
Thanks, Faye. I can't hear. I can't see you, Jana. You have an issue with your internet connection. 4. Raise your hand if you want to answer. Yeah, Bilal, with whom you are talking. Be focused with me, Bilal. Sir, read number 4. It's 4 root 5
minus 2 root 5 plus 5 root 5 minus root 5.
Actually, you can do it with the calculator one shot. Something like 4 root 5. Go out of the root. Don't write all of the question inside the root. Don't do like that. Like that is not correct. You have firstly to go out of the root and then complete the question. You know?
Yes.
It's negative 2 root 5 plus 5 root 5 minus root 5. Then it's 6 root 5. Let's do it with our mind. 4 minus 2.
2.
4 root 5 minus 2 root 5 is going to be 2 root 5. Plus 5 root 5 minus 1 root 5. 2 plus 5
7 root 5
minus 1 root 5.
6 root 5.
This is the answer that we got in the calculator before. It's correct?
Yes.
Any problem?
No.
Thanks. Yeah, first. Let's solve the first. It's root 7 plus root 7. Something like x plus x. X plus x equals
2 root 7.
yes, x plus x equals to x. But you know, if it is x times x, it's x squared. Be focused for the difference. Then root 7 plus root 7 is going to be 2 root 7. That's it.
Okay.
Talia, the next. 2 root 2 minus 3 root 2. It's something like 2 minus 3 and the root 2 spell itself. 2 minus 3 equals?
1.
No, it's not 1.
Negative 1.
Yes, excellent. 2 minus 3 equals negative 1. But if it is 3 minus 2, this is 1. You can do it with the calculator also. It's 2 root 2. Go out of the root minus 3 root 2. Then it's negative 1 root 2, which is negative root 2 without the 1. Both are correct. Yeah, Mu'taz. If you have something like 2 root 3 plus 3 root 3.
3 root 3.
2 plus 3.
5 root 3.
5 root 3. Take care. Or it's 5 cubic root 3. It's not correct. Because here the root is root 3 and the other root is also root 3. They are not cubic root 3. They are only square root 3. Then the answer must be square root 3. So cubic root is not correct. And the next, yeah, Noor, you have x, you have y, you need x minus y. What x?
X is 9
Root 5.
root
Minus y, which is 5,
root
root
3.
3. 9 minus 5 equals 4. Correct? 4 root 5 or 4 root 3. They are different. One is root 5 and the other is root 3. Then you can subtract them?
Yes.
No,
Why?
because they are different roots. I said before, only we can add and subtract. Only we can add and subtract the similar roots. They are similar? No, they are different. One is root 5 and the other is root 3. Then it's going to be 4 root 5 or 4 root 3. It doesn't work. We cannot add them. It is tell itself. This is the answer.
Okay.
Then, if you have something like 9 root 5 minus 5 root 5, this is correct, 4 root 5. And 9 root 3 minus 5 root 3, also it's correct, 4 root 3. But if it is 9 root 5 minus 5 root 3, they are different roots, then we cannot add or subtract them. They solve itself. Then it's 9 root 5 minus 5 root 3 itself, the same.
Okay.
I can't see you, ya Noor. Flip your camera. Yes, Bilar.
Mister, I couldn't understand the last question.
What the problem? If it is 9 root 5 minus 5 root 5, what the root here? The first root is 5 and the second root is 5. Then the answer is 5. And the first root is 3 and the second root is 3. Then the answer is 3. But here, one is 5 and one 3. Then it doesn't work. It's still itself. If you want to add or subtract any two roots, they must be similar. Both like each other. The first is root 5 and the other must be root 5. And the first is root 3 and the other must be root 3. Now, if it's one root 5 and the other root 3, then we cannot add or subtract them. It's still itself.
Okay, thank you.
You're welcome. Yes, Noor. Lower your hand. Nurhan, what's the problem?
Mister, the calculator cannot get the answer if I wrote this problem.
Yes, it's still itself on the calculator also. If it is 9 root 5 minus 5 root 3. Look at the calculator. I think your calculator is going to be right with itself again. Right? Rotate what?
I don't have it now.
Minus 5 root 3 equal, it's itself here. I have another calculator. Look on it. So the calculator made it itself also. Any problem? Is it clear? Yes. Okay. And the next part, we are talking about multiplying and dividing related after prayer. So we have Al-Maghrib prayer right now. Take a rest. You can mute yourself and you can close your camera. Assalamu alaikum. So right now, we talked about adding and subtracting. And the most important thing in adding and subtracting is that they must be similar roots. They must be similar roots. Right now, let's talk about multiplication and division. And this is an example. Okay, wait. Yes, this one. Firstly, before getting the question, we talked about the similar root. If it is something like 3 root 5 plus 8 root 5, then it's going to be 11 root 5. That's because 3x plus 8x equals 11x. And the same with the multiplication. If it is 3x times 8x, who knows? What the answer? 3x times 8x equals what? Raise your hand if you know. Yes, Sarah. 3x times 8x equals what?
24x power of 2.
Yes, it's 24x squared. It's the same with the roots if you want to multiply them. If it is 3 root 5 times 8 root 5, it's going to be 24 root 5 squared. And actually, the squared goes with the second root. The power of 2 deletes the square root. then it's 24 times 5. They are beside each other, then there is a multiplication process between them. It's 24 times 5 right now. 5 times 4 is 20. 0 and carry up 2. 5 times 2, 10 and 2, 12. Then it's 120. Let's check with the calculator. 3 root 5 times, go out of the root firstly, then click times 8 root 5. It's 120. It's the same. Again, 3 times 8, 24. Root 5 times root 5 equals root 5 squared. Root 5 to the power of 2. So right now, the root goes with the power. Each one delete the other. Then it's 24 times 5. 24 times 5 equals 120. And you can do it with the calculator. Okay? It's the same. It's the same like doing something like this. 3x times 8x equals 24x squared. Let's go for the question. Answer with me, Muhammad Izzat. Firstly, we need x, y. X, y means x plus y, x minus y, x times y, or x divide y.
صوت حضرتك بيقطع عندي.
If it is x like that, if it is x beside the y, then it's a multiplication or an addition question.
multiplication.
Multiplication. This means that x is multiplied by y. What's the value of x here?
7 root 5.
Time the value of y.
root 5.
It's something like 1 here. Then it's 7 times 1, which is 7. And the root 5 times root 5, root 5 squared.
Oh, okay.
Delete the power with the root. Then it's 7 times 5, not 75. Don't tell me it's 75 is not correct. It's 7 times 5. Okay?
Okay.
Which is 35. That's it. Check with the calculator. Write this on the calculator. 7 root 5. Go out of the root. Times 1 root 5. It's root 5 also. Without the 1, the answer is 35. Is it clear? It's clear, I think. So, Yanis, tell me the next. If it is x over y, what's the value of x?
7 root 5.
7 root 5. What's the value of y?
5.
Root 5 divided
Root 5.
root 5. 1.
0.
No,
Uh-huh.
1. Then it's 7 times 1, which is 7. That's it. Check the calculator. It's fraction. Then 7 root 5. Below the fraction, another root 5. Equals 7. Clear?
Yes.
Nadine. Something like 2x over y. 2 times x. What's the x?
X 7 root 5
Over y.
over root 5.
You know, root 5 up and root 5 down, you can delete each other. Can delete them like that. Root 5 over root 5, 1. Then you can delete them from the question. Okay? Then what's the remaining?
2 by 7.
2 by 7, 14. Check the calculator. Let's check. It's 2 times 7 root 5 over root 5. It's 14. Correct. Thanks. Lynn Abdel Halim. Where are you, Lee? I can't see you. Or you are Lamar. Rename yourself ya Lamar Abdel Halim and start your video. Yes, you missed. Answer the next. You have to catch what you missed with the record. 3 times y. What's the value of y? I can't hear you. It's root 5. Minus z. Z cubed. Look, be focused. It's z cubed. What's the value of z alone?
What?
What's the value of z alone?
2 cube.
Cubic root 2, but it's not z, it's z cubed. Then it's cubic root 2 cubed. Then the third power goes with the third root. Right now, it's 3 times root 5, which is 3 root 5 minus 2. Minus 2 without the cubic root because it's gone with the third power. Then it's 3 root 5 minus 2. And you have to let it like that. There is no any simplifying else. This is the answer. 3 root 5 minus 2. Because they are not similar roots. The 2 without any root. It's only 2. If it is 3 minus 2, I'll write 1. But if it is like that, 3 root 5 minus 2, then it's still itself. If it is something like that, 3 root 5 minus 2 root 5, you can't tell me that's 1 root 5. You can write it without the 1. If it is 3 minus 2, it's 1. But if it is 3 root 5 and the other without root 5, then it is still itself. Any problem? Thanks, Amr. Let's solve the next. Something, it's 5. Raise your hand if you want to answer. Mu'taz, what's the value of x?
7
7 root 5 minus 7 times y?
square
Root
root
5. It's 3 times 7 equals,
3 times 7 equal 21.
and the root 5 is still itself. Minus 7 root 5. They are similar roots?
Yes, تمام هتبقى
Yes, so you can subtract 21 and 7 equals what?
15.
14 root 5. This is the answer. Any problem?
No.
Nurhan, 6. The last is 4z power of 3 over 2y power of 2. What's the value of z? What is the value of z?
The value will be the 4
Cubic root 2 power of 3, because it's z power of 3 over 2 times y power of 2. Y equals
5 square
root 5. Root 5 power of 2. So the second power goes with the second root, the third power goes with the third root. Then it's gonna be 4 times what?
4 multiply 2
Over 2 times
times
5. 8 over 10. 4 over 5 in the simplest form. That's the answer. Check the calculator if you want. This is a fraction. 4 times, open bracket, cubic root 2, close the bracket. It's the third power. Down it's 2 times, open bracket, root 5, close the bracket, and the second power is 0.8. Actually, if you pressed SD button, this button is converted to 4 over 5. The answer is that we wrote before. Any problem?
Mister, can the next question I solve it alone without the help?
You want to solve another question without my help?
Yes.
Okay, I'll let you. It's the last one in this question. Then let's go for the check. Actually, this one is before this one. Let's check. Yes, this one is the next. Like that's better. Yeah, another page. Negative 7 root 2
Negative
times
7.
5 root 2. You have the mic.
It will be negative 7. I will make negative 7 plus 5
Times. So multiplication
time
equals.
equal negative 35
Ah,
and square root 2
square root 2 power 2.
power 2.
Then you can delete the root with the second power. It's gonna be what?
Negative 35 multiply 2
Which is,
equal negative 35.
check the calculator. Negative 7 root 2 times 5 root 2. Negative 70. Correct. Clap yourself. Congratulations. Thanks. Muhammad Al Hussein.
نعم يا مستر.
It's
5.
5 times 6 root 7 over 2 root 7 times negative 4. Firstly, look for the numerator. 5 times 6,
5 times 6 equals 30.
and the root 7 is still itself. And down 2 times negative 4.
2 times negative 4 negative 8.
So, what about root 7 over root 7? We can delete them together. Root 7 over root 7 equals 1. Then what is the answer right now?
30 over negative 8.
You can write it negative 30 over 8. Both are correct. And you can simplify it again by dividing both of the numbers by 2. Divide 2 up, it's negative 15. Divide 2 down is 4. Then it's going to be negative 15 over 4. If you want to convert it into a mixed number, then the nearest number for 15 in the table of 4 is 12, and the remainder is 3. Then you can write it negative 12 over 4, and beside it 3 over 4. 12 over 4 equals 3. With the negative sign, then it's negative 3 and 3 over 4. Check the calculator. It's 5 times 6 root 7 down. It's 2 root 7 times negative 4. Actually, it's negative 15 over 4. If you want to convert into a mixed number, then you can press shift, then SD. Shift, then SD. Let's say I did a problem, something like that. It's 4 equal, then shift SD. It's negative 3 and 3 over 4. Like that. Is it clear, ya Muhammad Al Hussein?
Yes.
Thanks. So the next Yanis. Ra'id. What is Ra'id? Why you aren't raising your hand, ya Ra'id? You don't want to answer? You don't want to answer?
No.
So why you didn't raise your hand?
Okay.
Raise your hand. Raise your hand so I can give you a question to solve it with me.
Hello. Hello.
You are hearing me?
Yes.
Raise your hand from the application.
Stop.
So answer with me the next, Yaron. Answer with me the next. Read the question. Get out of the session. Ahmed Sisi, you are sleeping?
No.
You didn't raise your hand, boss. On the calculator on the laptop, it's an application. Its name is like the name of the calculator of X991ES plus. So you can send me a message, WhatsApp message. Send me a WhatsApp message and I'll send you the application. Ahmed Sisi, solve me the next 3. It's cubic root 5 cubed by 2 root 5 over 5 root 5.
5 square root 5.
This is 5, correct?
Yes.
5 times 2.
10.
10 root 5. Over 5 root 5. Root 5 with root 5.
0.
1, not 0.
1.
10 over 5. It's 10 times 1 over 5 times 1, which is 10 over 5.
Okay. 10 over 5 will be 2.
Don't tell me it's something like cubic root 5 power of 3, which is 5 times 2 times root 5. Okay, it's times here also. If it is 2 root 5, this means it's 2 times root 5. Okay, it's 2 times root 5. They are beside each other like that. This means that they are multiplied together. Then it's 5 times 2 times root 5 over 5 times root 5. Someone could solve it like that. Mister, it's 5 times 2, 10, and 10 times 5 equals 50, then it's root 50. False. Only you can multiply the number with another number, and the root with another root. So you can multiply the root with the root, and the number with the number. You cannot multiply a number with another root. It's not correct. So 2 root 5 is the same as 2 root 5. But if you wrote it like that, as Mr. 2 times 5 equals 10, then it's root 10. It's not correct. This is not correct. Then it's 5 times 2, 10, and beside it the root 5. And down 5 times root 5. So it's 10 root 5 over 5 root 5. And right now you can divide root 5 with another root 5 because they are looking like each other. And the answer is 1. Then it's 10 over 5, and 10 over 5 equals 2. So, mister, it's so difficult. I can't do that. Get your calculator. Do it. Do it with the calculator. Let's do it. It's shift square root, which is cubic root 5 inside a bracket like that. Power of 3. And then times 2 root 5. And then 5 root 5. Yes, it's 2. That's it. You are doing like the African man. No, I don't know what was his name. Pilar.
Yes, miss.
Let's get another question. Wait, something like that. We will let this question. Okay, wait. Mute yourself, Pilar. Mute yourself. Wait. Let's right now talk about some properties we studied before. Properties on real numbers. We studied before the same properties, but on the integers the last year. You know, the closure property, the additive identity property, the additive inverse property, the associative property, and the distribution property. All of these properties we studied before with the natural numbers, and also we studied before with the integers the last year. Something like the first property is the closure, and the second property is the commutative property, and the third one is the associative property. The fourth one is the distribution one. The fifth is the identity property, and the sixth is the inverse relation property. So all of these properties, we will study them on addition and subtraction firstly, then multiplication and division. And the closure property means what? Means if you add or subtract any two real numbers, then the answer must be also a real number. If you have if you have a number like √2 plus 3√2, tell me below, is this number a real?
Yes, Mister.
Is that a real? So
Uh,
yes, this is a real number and this is a real number. So if you are adding two real numbers, then the answer must also be another real number. What the answer? It's 4√2. Is 4√2 a real number? Yes.
Yeah.
So if you are adding two real numbers, then the answer should be another real number. This is the closure property. Okay? Also in the subtraction is the same. Also in the multiplication and the division is the same. If you have √2 times 3√2 equals what? 1 times 3, 3. √2 times √2 squared, which is 2.
Yeah.
What's the answer right now? It's 3 what? Plus 2 times 2.
It's 3 times 2.
3 times what?
2.
2, which is 6. Is the 6 a real number?
Yeah.
The 6 is a real number. Then this is real, yes, and this is real, yes. So the answer is also real. And this is the closure property. What about the commutative property? The commutative means to flip the numbers. You know, if you have √2 plus 3√2, we can write it like that: 3√2 plus √2. We flip the places. This is the first and this is the second. Here we have the first as the second as the first. We started here with √2 and we started here with 3√2. Both are correct. There's the commutative property. You can flip the numbers without even changing the value of the answer. So when you are flipping the numbers, so with the real numbers, there is no change with the answer. The answer is still itself. If it is 2 plus 3, it's equal to 3 plus 2. No change. Is it clear?
Clear.
Also with the multiplication, if it is √2 times 3√2, is it equals to 3√2 times √2? Yes, both are equal. Let's firstly write here only the addition and here only the multiplication, because the subtraction and the division a bit different. Because when you something like the commutative property, if you flip the numerator with the denominator with the division process, it gives you the same answer? No. With the division process, we cannot flip the numbers. The numerator is still the numerator and the denominator is still the denominator. If you have 10 over 5, it's like 5 over 10? No, they aren't. So these properties, it's better to call them the addition and the multiplication only properties, without subtraction and division, because the subtraction and the division a bit different with some properties. A bit different. Okay. So let's go for the next property, the associative. Who knows what the meaning of the associative property? We studied before. You know, Yanis? Huh. You lowered your hand.
Yes.
You didn't know?
No.
What?
I forgot.
So the associative property is something like that. If you have √2 plus 3√2 plus 4√2, could you add firstly the first two numbers and then the answer added to the third one? It's correct. And you can do it like that. You can let the first number outside a bracket. You can get the second, the third inside one bracket. This means what? That you associated the first and the second here, and you associated that the third and the fourth here. It gives you the same answer. You know, 1 plus 3, 4, 3 plus 4, 7 root 2. What about here? It's also 4, actually it's 4 plus 4, which is 8, sorry. And here, root 2 plus 3 root 2 equals what?
Root 2, 4.
4 plus 4, 8. What about this? 3 plus 4,
7.
and there is another one, and then it's 8 also. Then, if you start adding the first and the second, it gives you the same answer. If you add the third and the fourth, or the second and the third, so if you add the first two numbers together and then get the third one with them, it's looking like the second with the third firstly, then adding the first to them. If you associated any two numbers and given the answer alone, after that, adding the third one to them, it gives you the same answer. Anyway, first and third firstly, and then add to them the second, first and second, and then add to them the third, second and third, and then add to them the first, it doesn't matter. Something like that. If you have 2 plus 3 plus 4, if you add these two numbers together firstly and then add the 4 to them, it's 5 plus 4, which is 9. Another one, Mister, I don't want to do it like that. I'll add 3 and 4, which is 7, and 7 and 2 is 9. Also, it's correct. Another one tells me, Mister, I'll add 2 and 4 firstly, which is 6, then 6 plus 3 to give you the same answer, which is 9. All of the ways are correct.
It's doing it in different orders, but it all gives the same answer.
Yes. Also, the multiplication, you can do the same. If you have root 2 times root 3 times 3 root 2, I think it's better to put it with the multiplication and the cubic root. Don't mind. It's 1 times 3 times 4, and this is cubic root, okay? It's 1 times 3, which is 3, 3 times 4, which is 12, and it's cubic root 2 power of 3. Then you can delete them together, then it's 12 times 2, which is 24. If another one told me, Mister, I'll do it like that. Firstly, I'll multiply the second and the third, like that. I'll start by the second and the third. Here we started by the first and the second, and here we started by the second and the third. Right now we're starting by the second and the third one. 3 times 4, 12, and it's cubic root 2 power of 2. Then this is 12 cubic root 2 power of 2 times this one, which is cubic root 2 power of 1. And there is another one. 1 times 12 equals 12. Cubic root 2 power of 1 and cubic root 2 power of 2. It's cubic root 2 power of 3. Then you can delete the third power of the cubic root. It's going to be 12 times 2, which is also 24. So it's also correct. Both of the ways are correct. Gives you 24. Another one told me, Mister, I'll do it like that. I'll multiply the first with the third firstly, like that, inside one bracket. And I'll let the second number only outside the bracket. Also give you 24. All of them are the same answer. This is root 2, yes, actually. There was a mistake. Thanks, sir. And the next we are talking about the distribution. Could you, first, could you tell me what the meaning of the distribution property? You know?
No, I forgot.
The distribution property is something like that. If you have root 2 and you want to multiply it by another bracket, which is something like 3 root 2 plus 4 root 2, what should you do in this case? You have to distribute the root 2 among the bracket. You got it?
Yes.
Then it's going to be root 2 times 3 root 2 firstly, plus, which is inside the bracket, and then root 2 times 4 root 2. That's it. Can get the answer of this. Root 2 times root 2 equals 2. Look for this. If you have root 2 times root 2, it's root 2 power of 2, which is 2.
It's 2, yes.
So if it is root 3 times root 3, you can tell me it's 3. in one shot. If it is root 5 times root 5, you can tell me, Mister, it's only 5. If it is root 6 times root 6, you can tell me, Mister, it's 6. The excellent student who can tell me that. The excellent one. If it is root 2 cubic, another cubic root 2, another cubic root 2 equals what? Also 2. Because it's cubic root 2 repeated 3 times. Then it's gonna be cubic root 2 power of 3. Then you can delete the third power of the second root, the third power of the third root, like what we did here. Then it's gonna be 2. So if it is cubic root 5 times cubic root 5 times cubic root 5 equals what? Was 5.
5.
If it is cubic root 8 times, let it 10, because cubic root 8 equals 2, and then cubic root 10, and then cubic root 10, then it's going to be only 110. If it is cubic root 11 times cubic root 11 times cubic root 11, it's going to be what? 11. But if it is something like cubic root 10 times cubic root 10, could you tell me, Mister, it's 10? No, it's not 10. It's cubic root 10 power of 2. So right now, we cannot delete the second power with the third root. It's not correct. So what the answer, Mister? The answer is the same, like itself. Like that. It's cubic root 10 power of 2, without any change. Okay?
Okay.
This may help you to in solving that question quickly. Might help you in solving the question quickly. It's root 2 times root 2. Yes, it's 2 in one shot, like that, one step. So root 2 times root 2, 2 times 3, 6. Okay, in one shot. Root 2 times root 2, 2 times 4, 8 in one shot, which is 14. That's it.
We can
That's
make
the
the addition first, and then
No, first you have to start by the multiplication. If you have multiplication and addition question the same question, you have addition and multiplication, then you have to stop by the multiplication.
But there is brackets. There's brackets in the brackets.
You know, in this part you can do it. Another one can do it like that. Root 2 times 7 root 2. Also, it's correct. Root 2 times root 2.
2
times 7.
14.
Is the same. Both are correct. But actually, this way works with some questions. It works with some questions easier than the other way. In some question, if you did it in this way, it's a bit easier than this way, and vice versa. You can do a question by this way. You can find that it's easier by the second way, and so on.
Yes, I understand.
All of these properties are talking about the addition alone and the multiplication alone. But this property only is talking about the multiplication with the addition themselves together. What about the identity? The identity property, or not the identity element. There is an identity element in multiplication, and there is another identity element in addition. Who knows that? Do it with the calculator, yes, sir. The calculator will write it as the same, because it's cubic root 2 or something like cubic root 5, all power of 2. It's not all power of 3. If it is power of 3, then you can delete this with this. Then it's root 5, or sorry, it's only 5. But if you have a question like that, if it is square root, then you can delete the square root with the second power. It's going to be 5 also. But if it is cubic root and a second power, can we delete them together? No, we can't. No, we can. Then you have to let it solve. It's something like cubic root 5 power of 2. And you can write it like that, cubic root 5 times cubic root 5. You know, I can write it like that. 5 times 5, 25. Then it's only 1 cubic root, and beside it 25. The same. Because also, if it is something like root 2 times root 2, you know, I can do it with another way. Something like 2 times 4, 2 times 2 equals 4. Below the square root, it's root 4. Root 4 equals 2. And also here, it's the same. If it is something like cubic root 2 times cubic root 2 times cubic root 2. You can do it like the following. It's only one cubic root, 2 times 2 times 2, which is 8. Then cubic root 8 equals 2, the same. So this one, if it is something like cubic root 10 times cubic root 10, you can do it like the following. It's only cubic root 10 power of 2. And you can do it like the following. 10 times 10, which is 100, below the cubic root. Both are correct. And the next lesson, we'll study how to simplify more something like this great roots. In this lesson, we are only focusing about the operations, but in the next lesson, we'll study how to simplify the big roots. If you have a root like cubic root 24 or square root 50, how to simplify them into a bit smaller roots. In the next lesson, we'll study them.
Mister, why in the first question we'll have 3 root when there
This
isn't
part?
this, yeah, there are 3 square root. Why we didn't write 3 above the
Both are
root
correct.
of 8?
I did it here. You can do it like that. It's correct. And like that is correct. Both are correct.
But it will equal 8 because I removed the cubic root because I
No,
put 3.
no. If you wrote it as cubic root 2 all power of 3, then you have to take only one cubic root from them. So it's only one cubic root repeated 3 times, then it's the same cubic root power of 3.
You mean it will be the same result when I do
Yes, both
2
are
above?
correct. If you did it like that, it's 2. If you did it like that, it's 2. And if you did it on the calculator, it's 2. Cubic root 2 times cubic root 2 times cubic root 2. It's 2.
Thanks.
So, you know the difference? Here, the first way, it's something like cubic root 2 times cubic root 2 times cubic root 2. Okay? Another way, it's cubic root 2 times cubic root 2 times cubic root 2. Be focused. Here, I'll take only one cubic root from them. Only one. And then I'll ask myself, how many times are repeated? They are 3 times, then it's the third power. Then the third power deletes the third root, and the answer is 2. But here, I write only one root, like that, and then I'll multiply the numbers inside the same root, without any powers. Without any powers. 2 times 2 times 2, 8. Then it's cubic root 8. Cubic root 8, 2. The same. Both are correct. You can do it by any way. Is it clear?
Yes.
So what's the identity? Who knows? You know, Sarah, what the identity element?
Yes, in addition, the identity element
Yes.
is 0.
The additive identity element is 0. While the multiplicative identity element?
It's 1 because it gives the same answer.
Yes, excellent. Thanks. So, what's the meaning of the additive identity element? The additive identity element is the number in which we can add it to any number and the value doesn't change. Something like 2 plus 0, it's 2. 0 plus 8, it's 8. The number which doesn't make any change in the addition process. Well, the number is 0. So what the number that doesn't make any change, the multiplication process, in which you can multiply by any number that doesn't change. It's the 1. 10 times 1 is the same 10. 1 times 2 equals 2. And so on. Then the number that doesn't change the multiplication is 1. And the number that doesn't change the addition is 0. So the multiplicative identity element is 1 and the additive identity element is 0. Any problem? Is it clear? Okay. So the last property, which is the inverse property. Actually, we have additive inverse property and we have multiplicative inverse property. What's the difference? Anyone know? I'm asking Sufyan. With whom you are talking here, Sufyan?
I don't know.
You are talking to yourself?
No.
So tell me, what's the difference between additive and multiplicative inverse? So if you have a number like 2, what's the additive inverse of 2? It's negative 2. That's it. in which if you add them together, the answer is 0. But if you have to, what the multiplicative inverse of 2? 1 over 2. In which if you multiply them together, the answer is 1. So the additive inverse is flipping the sign of the number. If it is positive, write it negative. If it is negative, write it positive. And while adding them together, the answer should be 0. You got it?
Okay.
But with the multiplicative inverse, you are flipping the number. You are flipping the number. The numerator becomes denominator and the denominator becomes numerator because the 2 was 2 over 1. Then when you get that, the multiplicative inverse of 2 is going to be 1 over 2. So 2 times 2 multiplied together equals 1. So can you, Sufyan, tell me what the multiplicative inverse of something like 3 over 2?
3 over 2.
Yes, what the multiplicative inverse of 3 over 2?
1.5.
3 over 2 equals 1.5. Yes, it's correct. But I'm asking about the multiplicative inverse. So you have to flip the number. The one is up, get it down, and the one is down, get it up. Then it's going to be 2 over 3. This is the multiplicative inverse. If it is something like 5 over 8, what's the multiplicative inverse?
8 and 5.
8 over 5. If it is something like negative 2 over 3, what's the multiplicative inverse?
3 over negative 2.
Yes, and you can write it as negative 3 over 2. Both are correct, which is equal 3 over negative 2. Both are correct. And you can write it like that. Look, you can put the negative up, and you can put the negative down, and you can put the negative alone. Not up, not down. Both are correct. If you put the negative beside the 3, it's correct. Beside the 2 is correct. Beside the fraction alone, it's correct. All are correct. So could you tell me what the multiplicative inverse of 3?
3. Negative 3.
No, negative 3 is the additive inverse. It's 1 over 3. Because the 3 actually is 3 over 1. Then when you flip the numbers, it's going to be 1 over 3. If it is 5.
1 over 5.
If it is 6.
1 over 6.
If it is negative 6.
Equal 1 over negative 6.
Or negative 1 over 6. Both are correct. But if it is negative 6 here, the additive inverse is going to be what? Only 6. So there's a difference between the additive inverse and the multiplicative inverse. If it is negative 7.
7.
If it is negative 8.
8.
If it is 9.
Negative 9.
If it is negative 3 over 2.
2 over negative 3.
No. Like that's the multiplicative inverse. If you wrote it as negative 2 over 3, this is a multiplicative, not an additive inverse. Then I say, make the fraction itself only change the sign.
Okay.
Then it's going to be what? Only 3 over 2. This is negative 3 over 2. This is positive 3 over 2. That's it. If it is something like negative 1 over 5, then it's?
1 over negative 5.
No. 1 over 5. Changing the sign. If it is negative, get it positive. If it is negative 1 over 8.
1 over 8.
If it is 5 over 3.
Negative 5 over 3.
That's it. You got it?
Okay.
So what's the difference between the multiplicative and the additive inverse? Could you tell me?
Multiplication inverse.
Flipping the numerator with denominator. So getting the down up and the up down. Or the additive inverse.
We change the negative positive.
Flipping the sign. Flipping the sign. Give the negative a positive and the positive is a negative. Adding any two additive inverse equals 0. Multiplying any two multiplicative inverse equals 1. So 5 over 3 plus negative 5 over 3 equals 0. Negative 2 over 3 times negative 3 over 2 equals 1. And so on. You got it? Yes, Nurhan?
Mr. Why when we said negative 5 over 3, when we make its inverse, we said it's 5 over 3. The negative is only in the numerator, not in the denominator too. So I just
You wanna do it like 5 over negative 3?
Yes, because it's just in the denominator.
No, both are correct. This is equal this, equal this. The three y's are correct. The three y's are correct. Anyone is correct.
Anyone mean that the negative is in both numerator and denominator?
Yes, you can put the negative up, you can put the negative down, and you can put the negative alone.
Okay.
Let's look for this. Raise your hand if you want to answer. Number 1, 2 root 3, bracket 5 root 3 minus 4. So which property you can apply?
This is associative.
No, it's the distributive property.
Oh, yes.
So right now, yeah, Faris, it's better to distribute, because if you try to subtract the numbers inside the bracket, then you can't, because you are different roots. So you have to distribute them. You must distribute the number outside the bracket and the numbers inside the bracket. The first multiplying process is 2 root 3 times what, Yasara?
Times 5 root 3.
Minus 2 root 3 times what?
Minus 4.
No, times 4. Because the negative sign we wrote here. Then it's 2 root 3 times 5 root 3. Yes, it's 2 root 3 times 5 root 3. Then it's 2 root 3 times 4, and there's 2 root 3 times 4. And the negative sign in the middle, I wrote it in the middle also. What about this multiplication process? It's 2 times 5, which is 10. Root 3 times root 3.
Root 3 power of 2, so it's going
Which
to
is
be
3. 3 in one shot. It's easier, which is 30. What about this? The same. 4
times
times
4.
2.
8
Root 3.
root 3.
This is the answer. If there's any other simplifying, could you simplify 30 with 8 root 3?
No.
And the last simplifying. We cannot simplify names. Number 2, Nadine. Let's see, Nadine, firstly, revise a very important note we studied before in the last year. Could you, Nadine, tell me, if you have a plus b all power of 2, how can you do this bracket in the second power?
What?
How can we solve this bracket? Something like the first power of 2, and then in the middle it's positive, and then first times second times 2, which is 2 times a times b, and the last is always positive, which is b, always positive to the power of 2. Then I wrote it a power of 2, and then a times b times 2, and then p power of 2. If the middle sign is positive, then the middle sign is positive. If it is something like that, a minus p all power of 2, what change? It's a power of 2 minus 2 times a times b plus p power of 2. So the last number is always positive, and the middle one is according to the bracket itself. If the bracket is positive, then the middle sign is positive. If it's negative, then the middle sign is negative. You got it?
Yes.
And we studied also if it is a plus p times a minus b. We can do it like the following. First times first, and then second times second, which is b times negative b, which is negative b times b. Correct?
Correct.
And we wrote it before as a power of 2 minus p power of 2. We called it before the difference between two squares. This is the difference between two squares. It's a difference between two squares. This is the first square and this is the second square. We have a difference between two squares. So could you tell me, Nadine, this one, which is 2 plus root 3 and then root 3 plus 7, which one of these? Is it the first case, the second case, or it's the third case?
The third case.
The third. Excellent. How can I do it? How can I do it? The first time the first. So actually, sorry, it's neither one of them. It's not one of them, because if it is the third case, it should be 2 plus root 3 times 2 minus root 3. Okay, they are the same, only the signs are different. One is plus and one was minus, but the numbers are the same, 2, root 3, root 3. Is it like that here? No. So how can you do it? Firstly, you have to distribute the first number among the first and the second, and then the second number among the first and the second. So what the multiplication or the first multiplication process? 2 times what?
2 times 3. 2
2
times
times root 3. And then 2 times,
2 times 7.
it's positive 14 or negative 14? Positive.
14.
Positive 2 times positive 7 to positive 14. Positive root 2 times positive root 3 times positive root 3.
Positive 3.
Positive 3, excellent, amazing. And positive root 3 times 7
7 root 3.
is something like that. This is 2 root 3, and this is 14, and this is 3, and this is 7 root 3. 14 and 3.
14 and 3 equals 17.
2 root 3 plus 7 root 3.
9 root 3.
Then it's 17 plus 9 root 3. This is the final answer. You know, you can do it with the calculator. Open bracket, 2 plus root 3, close the bracket, open another bracket, root 3 plus 7. Yep, it's correct. Thanks. Sorry, but we have to take another rest for the Isha prayer. You have a problem here, Nurhan?
No, I'm sorry for getting my hand raised.
Okay. So sorry for the late today. We are gonna getting another rest for the Isha prayer, and we'll go back again. Mute yourself and close your camera. Raise your hand for the next question. 3. It's 7 root 2 minus 5. Beside it, 7 root 2 plus 5. I think Nadine, right now is the third case, correct?
Yes.
The first number is the first number, the second number is the second number, and between them there is one time subtraction, one time addition, then this is the third case. How can you do it? The first time the first minus the second time the second. Then it's 7 root 2 times 7 root 2 minus 5 times 5. 7 root 2 times 7 root 2 equals what?
7 root 2 equals 14.
No, 49.
49 root 49 by 2.
Correct? And this is 25. 2 times 9, 18, 8 and 1, 8 and 1, 98 minus 25. 8 minus 5, 3, 9 minus 2, 7, then it's 73. Let's check with the calculator. Bracket, 7 root 2 minus 5, close bracket, another bracket, 7 root 2 plus 5. 73, correct. And the fourth one, Ferris, 5 root 3 minus 2, all part of 2. You can do it by two ways. And the first way that you can
The first, yes.
you can do it as two brackets like each other, the same. You can distribute it like this: first by first, first by second, second by third, second by first, second by second. Correct? This is a correct way. And there's another way in which you can apply the first rule or the second one. Is the first or the second? The first or the second?
No, it's the second.
The second, excellent. So we have to get the first number, which is 5 root 3, power 2, and then
And
the
then
other side,
5.
and then 2 times first times second, correct?
Yes, correct.
The second here is only 2, it's not negative 2, because the negative you wrote it here, then it's gonna be only 2, correct? So don't tell me it's negative 2 here, because the negative
Yes,
sign we wrote it here. We wrote
It's
before
always
the number, correct?
Yes, it's always positive.
And then plus what?
Plus 2 power of 2.
So the second power here, we can distribute it among the 5 and the root 3. Then it's 25 times 3. 5 power of 2, 25. Root 3 power of 2, 3, correct?
Correct.
Minus 2 times 5, 10 times 2, 20, root 3 plus 4, 75.
Yes.
75 plus 4
79.
and negative 20 root 3. This is the answer. Let's check the calculator. Bracket 5 root 3 minus 2 close bracket all power of 2. Yep, that's correct. Yeah, Anas. Yeah, Anas. Yeah, Anas.
Yes.
Get the next. This one. How can you do that? Distributing. It's 5 root 2 times what? It's first. 5 root 2 times the first. and then minus 5 root 2 times the second. Okay?
Okay.
5 times 3.
5 times 3, 15.
So this is root 2. So root 2 times root 2, 2.
2.
Root 2 times root 2, 2. Root 3 times root 3, 3. Root 8 times root 8,
8.
8, and so on. Okay? Minus 5 times 2, 10. And root 2 times 1, because there is nothing given the root in the root part, then it's the root 2. Okay? Then 30 minus the root 2. Check the calculator. You can check the calculator. 5 root 2 outside the bracket, then bracket 3 root 2 minus 2. 30 minus the root 2. Correct?
Yes.
Start your video. Zani is closing his video. You should start your video. Minus 5 stars from each one. Abdul Malik. The next. The first is the first, the second is the second, then there's difference between two squares. First times first and second times second. It's 2 root 3 times
times 2.
root 3 minus 3
3.
times this rule. It's 4, 2 times 2, 4, and root 3 times root 3,
Root 3 times root 3.
3, minus 9. Then it's 12 minus 9. 12 minus 9,
3.
that's it. Sarah? Huh? First power of 2, after that
2
plus
root 5
2 times 2 root 5 times,
3 times 2.
yes, also it's correct.
3 power of 2.
This is 4 times 5, correct?
Yes.
2 power of 2, 4, root 5 power of 2, 5, plus 4 root 5 times 3, which is 12
12 root 5
root 5, and this is 9.
plus 9.
20 plus 9,
29
29 plus,
plus 12 root 5.
and you can check the calculator. The first is the first, the second is the second. No. Is that a difference between two squares, Sarah? We can apply the third rule here?
Yes.
No, because this is 5 and this is 1.
Okay.
So what the correct way?
The first
times
one times the
first.
first one and the second
Yes,
one
it's
times
4
the second.
times 7. 2 root 7 times 2 root 7, let it like that, 2 root 7 times 2 root 7, and then plus 2 root 7 times 1,
1
and then
negative
minus
5 times 2 root 7.
5 times 2 root 7, and then minus 5 times 1. 2 times 2, 4. Root 7 times root 7, 7. And this is times 1 itself. And this is equals 10 root 7, and this is 5. So 28 plus 2 root 7 minus 10 root 7 minus 5. 28 minus 5,
23
and 2 minus 10,
negative 8 root 7.
that's it. Okay. Right now, we're starting talking about the simplifying. If you have a fraction like that, the problem in this fraction is its denominator. If the denominator is q dash, a rational number, this is a problem. So what we have to do, if you have a question like that, 9 over root 3, its denominator belongs to q dash. What we should do, to get rid of this denominator and to write instead of it a real number, then we have to multiply this number by another fraction, its numerator and its denominator, like the denominator that we want to get rid of it. Then it's 9 root 3 over root 3 times 3, which is 3. 9 over 3, 3. Then it's 3 root 3. That's it. So right now its denominator becomes 1. So like that, we get rid of the irrational number, the denominator. And you can do it with the calculator. 9 over root 3, 3 root 3, like what we get. So in the first one, if it is 9 over root 3, you can multiply it by root 3 up and down. In the second one, if it is negative 3 over root 2, you can multiply it by root 2 over 2. And after that, if it is something like 5 over 3 root 5, you can multiply it by root 5 up and down without the 3. So we want to get rid of this root from the denominator. Then we multiply the number or the fraction by another fraction, it's numerator and denominator, like that. Denominator that we want to get rid of it. Root 3 up and down, root 2 up and down, root 5 up and down. This is 9 root 3. over 3. 9 over 3, 3. 3 root 3. Up it's negative 3 root 2. This is times this is negative 3 root 2. And down is 2. This is the final answer. 5 times root 5, 5 root 5. 3 still itself. Root 5 times root 5, 5. So the 3 is still itself. Root 5 times root 5, 5. Then it's 5 root 5 over 15. Divided 5, 1, divided 5, 3. Then it's root 5 over 3. This was over 1 belongs to R. And this is belongs to R, and this is belongs to R. This is our why in this question. We want to get rid out of the rational number in the denominator and write instead of it a real number. How can we do that? By multiplying the fraction by another fraction. Its numerator and denominator is the same denominator that we want to get rid of it. So who can tell me, what about this? If it is like that. Raise your hand if you know this question. 3 over root 7. We have to multiply it by what?
Root 7.
Yes, root 7 over root 7, up and down. Because
Yes,
root 7 over root 7 equals 1. Then it's not like you are multiplying it by 1, so the value doesn't change.
Yes.
It's 3 root 7 over?
Over 7.
So the denominator was Kirash. Right now the denominator
Is Rush.
This is what we want. What about the next years?
Also multiplied by root 3 up and down.
Root 3 up and down. It's negative 4 root 3 over
3.
the denominator was irrational, and right now it's real. This is what we want. The last one, 9 over 2 root 6. We have to multiply by
Root 6.
root 6
Up and down.
up and down.
Yes.
It's gonna be 9
It's gonna be
6.
9.
over 2 times 6. 2 itself, root 6 times root 6 is 6, correct?
Correct.
Over 12. Divided 3, 3, divided 3, 4. Then the simplest form, it's like that. You know, you can do it with the calculator. It was a rational number. Right now, it's a real number. Let's write this one on the calculator to check our answer. It's 9 over what? 2 root 6. Oh, wow. Amazing. The calculator get it right by 1 step. Actually, if you are in an exam, you can do it with the calculator. Okay.
We need the steps.
Only if it is an essay question. Only if it is an essay question.
It's easy. Okay.
It's easy.
It's easy if it is choose. Yes.
Correct. I think we forgot a question. Yes. Where is the place of this question? I don't know actually. Okay, let it right now. Let it right now. Oh. Da, 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 da. Oh. So it's the same question, but there is another problem. It's the same question, but there is another problem. If it is something like that, and another question, if it is something like that. And this question, we solved it before as root 2 up and down. But in something, if you have something like this question with an addition or a subtraction sign between the two numbers in the denominator, then you have to multiply it by the conjugate of it. What's the meaning of the conjugate? If it is 4 minus root 2, then you have to multiply it by 4 plus root 2 up and down. If it is only root 2, multiply it by root 2 up and down, because it's multiplied by the 4 and the multiplications, then you can multiply it by the root 2 only up and down. Don't look for the 4. But if there is a subtraction or an addition sign like these questions, then you have to multiply by the conjugate of it. What the meaning of the conjugate? The conjugate is or mean that you have to multiply but by the number with the flip sign. If it is 4 minus root 2, then it's going to be 4 plus root 2 up and down. So right now it's 4 plus root 2 times 1. And here it's 4 minus root 2 times 4 plus root 2. So up it's 4 plus root 2. Down, first times first and second times second, because they are difference of two squares. 4 times 4, 16, minus root 2 times root 2, 2. then the answer is 4 root 2 over 14. Also, you can write it as the following: 4 over 14 plus root 2 over 14. Both are correct. This is correct and this is correct. And this you can simplify and divide by 2, 2 divided by 2, 7. This is correct, this is correct, this is correct. And this is what we did before. So this is 1. Let's go for 2. Omar, 4 over 3 plus root 5. Then you have to multiply by what?
root 5.
Here it was 4 minus root 2. I wrote it 4 plus root 2 up and down. If it is 3 minus root 5, plus root 5, then you have to write it
minus root 5.
minus root 5 up and down. Up, it's 4, open bracket, 3 minus root 5. Down, it's something like that. 3 times 3, root 5 times root 5. 3 times 3, 9. Minus root 5 times root 5, 5. Okay?
Okay.
This is the 4. This is the bracket. And 9 minus 5 equals 4. You can delete the 4 with the 4. Then the answer is 3 minus root 5. And the last one, solve it with me also. You have to multiply by what?
So it will be times 4 plus.
No, it's root 3 minus 2. Then it's root 3 plus root 2. Like that. This one. The
Yes, sir, I
denominator is with the subtraction. Then you have to make it with the addition up and down. Okay? Up times 1 still itself. Down, first times first, minus second times second. Root 3 times root 3, 3. Minus root 2 times root 2, 2, which is 1. So you can delete it. It's only root 3 plus root 2. You can do it with the calculator? Yes, actually. Let's write it on the calculator. 1 over root 3 minus root 2. Yes, it's the same. Okay? Actually, the next is the same. We'll not solve it. Only we have to multiply this one by what? 1 over 5 plus root 3 times what? Actually, if it is 5 plus root 3, then it's 5 minus root 3 up, 5 minus root 3 down. That's it. You can complete. 11 over 4 minus root 5. You can multiply by 4 plus root 5. This is subtraction down. Then put it an addition question up and down like that. If it is 4 over root 7 minus root 3, you can multiply it by the conjugate of the denominator, which is root 7 plus root 3 over the same root 7 plus root 3. You can solve it. In this question, he asking you find the additive and the multiplicative inverse. Who know the first? 2 root 5. What's the additive inverse? First.
Negative.
Negative 2 root 5. What's the multiplicative inverse?
1 over 2.
But there is a problem. It's 1 over 2 root 5, but it's not in the simplest form. How can you simplify it?
Times 2
root 5 up and down.
Yes, root 5.
If there is an addition sign here?
No.
If there is an addition sign, then you can multiply by 2 minus root 5 over 2 minus root 5. But if they are multiplied together, then only get the root 5 up and down. Okay? Then it's root 5 over 2 times 5. This is the 2. Root 5 times root 5, 5. You got that?
Yeah.
10. Then it's root 5 over 10. That's it. You can do it with the calculator. Write this on the calculator. 1 over 2 root 5. Root 5 over 10. Correct?
Correct.
Solve the next also. It's 4 minus root 3. What's the multiplicative inverse? The additive inverse?
The inverse, negative 4, positive.
Yes, excellent. And the additive inverse means to put a negative sign outside the bracket like that, and instead on which we can flip the sign both numbers, then it's going to be negative 4 positive with 3. This is positive, we have to write it negative. This is negative, we have to write it positive. Okay? If it is the multiplicative inverse, how can we do it?
1 over a negative 4
minus
times 4 plus
yes,
root 3.
Excellent.
Up and down.
Up and down. Up, it's 4 plus root 3 only. Down, 4 times 4, 16. Root 3 times root 3, 3. 16 minus 3, 13. That's it. Let's check. 1 over this one. 1 over 4 minus root 3. Oh, yep. It's correct. You know, we can write it like that. 4 over 13 plus root 3 over 13. Also is correct. I distributed the denominator among the two numbers. You know?
Yes, I understand.
At the same. So, the additive inverse.
7 root 3.
The additive inverse, 7 root 3. The multiplicative inverse.
1 over 7 root 3.
No, it's negative 1 over 7 root 3 because it was negative 7 root 3. You know?
Okay.
Times what?
Times root 3.
Up and down. What about this? The additive?
Negative root 3 over 3.
Yes. The multiplicative?
3 over root 3.
Times root 3 over 3. Always put it in the simplest form. You can complete, okay? So the additive, be focused.
Negative 2 root 5, positive 1.
Yes, excellent. Flip both the number sign. It's negative instead of positive and it's positive instead of negative. Well, the additive inverse.
1 over 2 root 5, negative 1.
What else?
Times 1 plus 2 root 5, up and down.
2 root 5 plus 1, up and down. Both are correct, okay? You can complete. I think it's the same. Yes, the same. And this question, he means a cuboid whose dimensions are 3 meter, 5 root 3 meter, and 2 root 3 meter. Find number 1, the volume. Number 2, the total surface area. How can you get the volume, ya Lamor? The volume of the cuboid. Volume was length times width times height.
Right.
Length, width, and height. These are the dimensions. What about the total area? You know, we started before. 2 times length, width, plus length, height, plus width, height.
Right.
Multiply together, all of them. What the length? 3. What the width?
5, the 2.
Yes, you are correct. You are correct. Okay. 3 times 5, 15 times 2.
30.
What about root 3 times root 3? So, yeah, be focused. 3 times 5, 15. 15 times 2, 30. And root 3 times root 3, 3. Then it's 30 times 3, which is
90.
centimeter cubed because it's volume. With the area, it's centimeter squared. Okay?
Okay.
2 times length times width. 3 times 5 root 3. Plus 3 times 2 root 3. Plus 5 root 3 times
2
excellent.
2 square 3.
2 root 3. Okay?
Yeah.
So as a 2 itself, this is 15 root 3. This is 6 root 3. And this is be focused. It's 10 times
10 times root 3.
no. Root 3 times root 3 equals what? 3. 3. So it's 10 times 3. Okay?
Mister, why didn't we just
Root 3 times root 3 equals the 3. Okay?
Okay.
Root 2 times root 2, 2.
2.
Root 5 times root 5.
5.
Then root 3 times root 3.
3.
5 times 2.
10.
3 times 10.
30.
That's it. Okay? 2 times 15, and then 2 times 6, and then 2 times 30. 2 times 15, 30 root 3. 2 times 6, 12 root 3.
3.
2 times 30, 60. 30 root 3 was 12 root 3 equals 42 root 3
root 3.
plus 60. This is the answer. Let's check the calculator. 2 times open bracket 3 times 5 root 3 plus 3 times 2 root 3 plus 5 root 3 times 2 root 3. Oh, that's correct. You know, we can write it like that. Get the 60 first and then a 42 3 second. You know, it's correct. It's a commutative property. Both are correct. Okay?
Okay.
This
So
is
both are
correct and
correct?
this is- both are correct.
Okay.
But if it is negative here like that, then you have to put negative here with the sixth. Okay?
Okay.
But
Thank
it
you.
was positive. This is the same. This question. And this is the last question. A cube whose volume is 27 cubic centimeter. Find number one, sum of its edges. Number 2, total surface area. How can we get the sum of the edges? Firstly, we have to get the edge. So number 1, the edge with the side length, it's cubic root of the volume. So it's a cubic root 27, which is 3. Number 2, the sum of edges. How many edges are there? Actually, the cube has 12 edges. Each one is 3, then it's 12 by 3, which is 36 centimeters. This is the sum. This is the answer. What about the total area? It has a rule. Firstly, we have to get the side length. We get it before, which is 3 centimeters. Right now, you can get the total surface area, which is 6 times s power of 2. I will write in the notes all of the rules that we have studied before about the cube, the cuboid, and these questions. Okay? It's 6 times 3 power of 2, which is 9. 6 times 9, 54 centimeters squared, because it's area. And the last one, it's not whom that I did the lesson, okay? It's not whom that I did the lesson. Yeah. Cuboid, whose dimensions are 2 root 2, 7, and 5 root 2. Find number 1, total surface area. Number 2, its volume. We solve the question like total surface area equals 2 times length width plus length height plus width height. You can do it. Volume equals length times width times height. You can do it. This is the length, this is the width, and this is the height. And finally, we finished. So take care about your quizzes. Take care about your homework. If you didn't do the quiz or the homework, I'll send a message to your father and your mother. You can see your grades from the sheet. The link of the sheet is in the description of the WhatsApp group. And finally, you can go. مراويح مراويح مراويح.